Good morning, everyone. Yesterday, I received a private message from a friend asking whether rigid flex PCBs can reduce routing. The answer is definitely yes. Today, I'd like to share how rigid flex PCBs achieve this routing efficiency. Rigged flex PCBs integrate rigid sections plus flexible sections into a single unit, eliminating the need for additional wires or connectors required by purely rigid or purely flexible boards. For example, in devices containing both fixed modules like motherboards and moving parts like foldable screens or robotic joints, purely rigid PCBs rely on wiring connections, while purely flexible PCBs might require multiple segmented assemblies. Rigged flex PCBs utilize the flexible section as a bridge integrated in a single molded part. This eliminates transition points, naturally saving space for wiring and connectors. Is your device's internal layout complex, forcing circuitry to teeter? Rigid flex solves this. The rigid section adheres to fixed areas, while the flexible section bends and conforms to curved surfaces, directly matching component placement. Unlike pure rigid designs that lengthen routes to avoid obstacles, or pure flexible designs requiring support brackets, circuits can run straight, reducing length and indirectly saving routing costs and space. To maximize routing savings with rigid flex, note two key points. First, clearly define the device's fixed zones and immovable zones to precisely match rigid and flexible sections. Plan routing paths in advance to prevent strain on wires when flexible sections bend, maximizing the routing savings advantage. Got it now? If not, click the link below the video for a more detailed explanation. That's all for today's video. See you tomorrow. Bye.